Layer 2, data link layer. So the data link layer establishes, maintains, and decides how transfer is accomplished over the physical layer. So basically now what we're talking about are frame types. How is that content encapsulated and put over the wire? Christopher earlier mentioned MAC addresses, media access control addresses. They're defined at the data link layer. These are hexadecimal addresses assigned to a physical network card for or to uniquely identify these cards.
In this case, MAC addresses ensure, in theory, although I don't think I've ever seen an example of this in the real world, they ensure uniqueness worldwide for network devices.
Correct. They actually, okay, so this is a little bit older. They had a problem where they gave, so for hexadecimal addresses, they assign different manufacturers different addressing schemes or different addressing assignments. For a while they had, and I don't even remember the names of the companies, they gave them the same assignments. So now they were putting out network cards that had the same MACs. I was at a training center, and again, this was a while ago when people had problems with network cards and you had to be really careful with static electricity. So in a training center, you're moving hardware. You're ripping open the case, you're removing network cards. So moving network cards, you use static would blow the address. So now you might have multiple systems that have the same MAC address. And the error that you would get is you'd bring one system online, it would be able to use the network. When you brought the other system online, it would blow the first system off the network. And then as you used each system on the network, it would blow the other system off the network. So
sounds like fun.
Oh, it was really interesting to troubleshoot.
I imagine.
I would say it was good times, but it was not good times. It was the opposite of good times, actually. So network interface cards and bridges are examples of devices at this layer, and the unit of measurement at this layer is frames. So media access control, which we've talked a bit about already, ensures unique addresses for the different devices. We've talked about what happens if devices don't have unique addresses, and manufacturers are typically assigned ranges of addresses. There are 6 octets in length, written in hexadecimal.
And we're actually going to see an example here on the next slide.
So
it's animated, so not just by clicking.
Okay.
We'll get to an example in just a moment.
And props to Christopher. This is some of his graphic magic here. So know that all this graphic amazement is coming from Christopher.
Unless you hate it, in which case it was someone else entirely.
A vendor did it,
yes.
I guess. Layer 2 switches are hardware-based and use the MAC addresses of each host computer network when deciding where to direct data frames. We've talked a little bit about switches already. So ports on the switch are mapped to different MAC addresses on the system. So if we look here, we'll see that, hey, these two ports are assigned to these two MAC addresses. So when a packet comes in for a specific device, it will only send to that specific device.
Yeah, and in this case, 2 things to note here. At the very top it says layer 2 switches. That is a valid term, although 99% of the time when you hear the word switch, it's a layer 2 switch. We probably won't get too complicated in this session or in this course and talk about layer 3 switches, which do exist. Little much to go into, considering it's actually overlapping with routers and switches. We're not going to go there. So usually when you hear the term switch, it's a layer 2 switch. And these addresses, they're not assigned per se to, say, the ports on this device, whereas a router is going to have IP addresses on the device. These, it just keeps track of. The switch knows what's plugged into it. It creates a little table, so it knows port 1 is that first MAC address. Port 6 is that second MAC address. It just knows that itself.
And so people aren't confused. People now will see devices that are switches and routers. So a lot of things that you'll see in the marketplace now, consumer-based devices, have multiple functionalities to them.
That's true, and a lot of it, it's a couple of different things. One, it's the combining of functionality. A traditional router would have a network card for a network and a network card for another network, and that's what would plug into it, and it would do the routing between the two. What you see now at home, especially if you're seeing a router, you know, you go to the store and you buy a router for your internet, That is a router in that it does route traffic from your network to, in this case, the internet. It's also a switch because they provided you 4 ports to plug computers in your home or in your small office into. So it does both. It's not one device. Essentially, it is 2 devices in that box. It's a switch and a router at the same time.
So VLANs, we've discussed VLANs a little bit already. Layer 2 switching can also allow for virtual networking or virtual LANs to be implemented. Again, this enables you to segment different areas of the switch, so entire bandwidth isn't thrown over either the switch, or you can allow communication of different segmented areas using the same switch.
Another fun little animation for this one.
Okay, so basically, like we just said, you can associate, hey, these 4 ports are one network, these 3 ports are another. Maybe you have accounting on one network, you have management on another. You do not want those to intercommunicate. You can use a virtual LAN to do so.